All right, ready, set, go. Here we are, Systems 4.3. So, first thing we're going to do is write linear equations in standard form and slope-intercept form. So we want to rewrite the given equation so that they're in slope-intercept form, okay, which means the y is by itself. So to do that, I've got to get rid of this 7x. So I'm going to subtract it because it's a positive 7x. That becomes 0. I'm left with negative 14y equals. Now, negative 56 and negative 7x can't be combined because remember, this 7 is a coefficient. It's an amount, not a number. So that means that I just go negative 7x minus 56. And just keep that there. Then to separate negative 14 and y, I divide by negative 14. Okay, and I get positive y equals negative 7 over negative 14 is going to be a positive 1 over 2 x. Then negative 56 and negative 14 are going to give me a positive. So 56 and 4 divided by 14 is 4. So I get 1/2 x plus 4. Okay, number 2. This time it's a negative 8x, so I'm going to add the 8x to both sides. Notice we're kind of doing a similar thing that we did over here. It becomes 0. Negative 2y is equal to, again, 6 and 8x can't be combined. Now, I could write 6 plus 8x, and even though the x is in different position, it's still with its coefficient, and it's still technically the same thing, right? b plus mx is the same as mx plus b. But divide by negative 2 on everything. That becomes positive y equals 6 divided by negative 2 is negative 3. 8 divided by negative 2 is negative 4. So I can put plus negative 4 or just minus 4. And finally, number 15, subtract the 15x here. I'm left with 9y equals negative 15x plus 45. Divide by 9. I get y equals, okay, 45 divided by 9, that's easy, that's 5. Okay, no, my x is there. 15 over 9, I can divide by 3, and that would be 5/3, which it's slope, because it's with the x, so probably just want to leave it like that. All right, writing inequalities from a real-world problem and graphing inequalities. So on a final 4 creative writing course, Ben was required to write a combination of at least 10 poems or paragraphs. Ben knew that each poem would take him 30 minutes to write, while a paragraph would only take 10 minutes. Ben was given 2 hours to complete the exam. Okay, write an inequality to model each constraint. Okay, here's our hints. One is time, the other is the number of items needed. Okay, then also let x be the number of poems written, okay, and y the number of paragraphs. So I know I need at least 10, so an easy one to do is to realize that x, the number of poems, plus y, the number of paragraphs, has to at least be 10. Okay, can it be greater than? Yeah, but at least has to be equal to. Okay, so there's one of them. So now, says let's graph an inequality. I'm just going to use this as my y-axis. This is my x. And x is poems, so that's poems. And so this would be paragraphs. I'm just going to put paras. Okay, do the same thing here. Okay, so what are some options to graphing this? Well, first, if I only did poems, I would have to at least do 10 of them, right? So if I go just poems, I go up to 10. So that's where my poems would be. Now, if I just did paragraphs, it would also be at 10, right? Because there's no number here. Okay. And I could do any combination in between. So I could do 1 and 9, or 2 and 8, or so on and so forth. Okay. So I can do that. That line would represent if I only did 10. But what if I did more? Okay. That would represent these points here. Okay. So really, any of these points beyond my line would work for that. Okay. All right. Now the time. So it takes 30 minutes to write a poem. So to represent the number of poems I take, each one I have to multiply by 30 minutes. okay? Then a paragraph is 10, so each paragraph I write would take 10 minutes, so 30x and 10y. Then I add those together, okay? And they have to be within 2 hours, okay? So this would have to be less than, or it could be the exact time of 2 hours. Now, here's a problem. 2 hours and minutes don't really mix, do they? So let's put our 2 hours in terms of minutes, which would be 120 minutes, okay? And again, let's take this same approach. Here's my poems. Here's my paragraphs, okay? So if I only did poems, that would be like 30x is less than or equal to 120, right? So if I divide by 30, I would get x is less than or equal to 4. So I could only do 4 poems. Okay, not very many. But what if I only did paragraphs? Okay, they're 10 minutes each, so that's pretty easy to see that I could do 12 paragraphs, right? In that same amount of time. So right here, okay, so there's that line, okay, and then it has to be less than that, so I'd have to shade in time-wise, okay. Now it'd be interesting to, I guess, take this one step further, but they didn't require this, to look at them together, huh? So if I graphed them together, I could then look at which portion they overlap, and I can see that really there's only this small area that would work. So most likely I would end up only being able to do 1 poem and 9 paragraphs. Or I guess to do only paragraphs. Okay. Yeah, something like that. Okay, interesting though to think of that. All right, so now let's talk about, for each relationship below, one representation is provided. Create the remaining representations and explain any connections you notice between representations, okay? So we've got a table, okay? Day 1, 8, cost was 8. Day 2, 16, so create a context. So maybe bill, rents, what is he going to rent? How about he rents, drawing a blank here, we'll say a car for $8 per day. Okay, so at day 1, he paid $8. At day 2, paid 16, because we're adding 8 each time, right? Okay, so on day 0, the cost would be 0. So, you know, if I'm graphing this, 0 right here, 1, I'd go up to 8, which maybe I'm going to count by 2s. There's 8. That would be 16 right there. Okay, and my graph would look something like that maybe. Okay, for my equation, I can just go y equals, we start at 0, we're adding 8 every time, and there's my graph. What I should notice, right, is that 8x, we see it right here, see it right here, and I see it as it goes up 8 each time it goes over 1, which are the ones I can see right here. Okay? All right, number 6. So Claire earns $9 per week allowance. Okay, so we would have week and total earned, right? So at 0 weeks, she hadn't earned anything. So at 1 week, she would earn 9. 2 weeks, she would now have 18. At 3 weeks, she would have 27, and so on, right? Count by 3s on this graph. Okay, so graphing this, again, 0, 0, 1, 9, 2, 18, right? Oops, And I messed up on that, didn't I? Be 9, 12, 15. There we go. 18, 21, 27, right? So 0, 0, 1, 9, 2, 18, and then 27. So it looks something like that. So our equation, y equals 0 plus 9x. And again, we can see those same growth numbers as we did on the other one. Okay, now we've got an equation just 3x. Okay, well, y equals 3x. We start at 0, slope of 3 over 1, so to the right 1, up 3. To the right 1, up 3. Up 3. Okay, so it would look like that. Okay, so my x and my y, so we'd start out at 0, 0, then at 1 we'd go up 3, 2 we'd go 6, 3 we'd go 9, and so on. So to create a context here, okay, we could say Elvira eats 3 tacos every day, which would then change this to days and tacos eaten. Total tacos eaten, huh? TTE. Very important acronym. I can't draw my periods. All right, last one. We've got an equation. Okay, so I know probably going to want to go 0, 1, 2, 3, 4. So at 0, we're clear up here. So we're assuming we're counting by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. So start at 9. Then we go down to 8. Then to 7, 6, 5. Okay, and seconds and sand. Okay, so in seconds we're getting less sand. So Horatio created a sand castle and every second it loses sand from the tide. Probably not exactly true, but something like that. So our equation, y equals 9, where we started, subtracting 1 each time, so we get 9 minus 1x. Okay, and there we go, guys. That's all there was to it.